This is the first of a couple examples that we'll do involving buffers. In this problem, we're asked to calculate the pH of a solution that results from a mixture of 125 milliliters of 0.1 molar ammonia with 250 milliliters of 0.1 molar ammonium chloride. Now, the way I know that this is a buffer is because it contains both a weak base and its conjugate acid, right? So this ammonium chloride, when it dissolves in water, because it's an ionic compound, it's going to completely dissociate into ammonium ions and chloride ions. So for the purpose of this problem, I'm not really interested in the chloride ions because, of course, chloride ions are pH neutral. What I'm interested in is the ammonium ions. And if I have 0.1 molar ammonium chloride, then I'm going to have 0.1 molar ammonium. So whenever we're dealing with buffers, we want to know the chemical reaction that we're dealing with. And we can either write it as the dissociation of the weak base or the dissociation of the weak acid. And for consistency, I always write them as the dissociation of the weak acid. So the chemical equation that I'm interested in for this buffer is the weak acid plus water and if ammonium is an acid, it's a proton donor, so that's going to make H3O plus. And NH3. Now, in principle, what we need to do to determine the pH of this solution is work an ice table problem. But if I have a buffer, and if I know it's a buffer, then there's a simplified way to determine the pH, and that's using the Henderson-Hasselbalch equation. And the Henderson-Hasselbalch equation tells me that the pH of the solution is going to be equal to the pKa of the weak acid plus the log of the concentration of the base divided by the concentration of the acid. And so I need three things in order to determine the pH. I need to know the pKa, the concentration of the base, and the concentration of the acid. So first, let's get these, the concentrations of the base and the acid. So for the base, I'm told that I have 0.1 molar ammonia, but that was before I mixed the solutions, right? So when I add the 125 milliliters of the ammonia to the 250 milliliters of the ammonium chloride, I'm going to be diluting both the ammonia and the ammonium chloride. So I need to calculate the new concentrations. And so I'm going to do that using M1V1 is equal to M2V2. So for the ammonia, I want the new concentration, so that's going to be M1V1 over V2. So the M1 is 0.1 molar. The V1 for the ammonia is going to be 125 milliliters. And the V2 is going to be the sum of the 125 plus the 250. So 125 plus 250 is going to be 375. And so, right, my milliliters will cancel. And when I multiply that out, I get 0.033 molar for the concentration of the ammonia. And I'll do the same thing for the ammonium. So in this case, my M1 is 0.1 again. But now my V1 is the 250 milliliters. And it'll have the same final volume. And so I get 0.067 molar for the ammonium. All right, the next thing that we need to do, now that I have the concentrations, is I need to determine the pKa. So we'll do that on the next slide. Okay, so we were given the Kb of ammonia, but what I need is the Ka for the ammonium. But what I can do is, first I'll find the pKb. So the pKb is the negative log of Kb, or it's going to be the negative log of 1.76 times 10 to the minus 5. 10 to the minus 5 So the pKb, I get 4.75. All right, and then I'm going to use that the pKa of the conjugate acid plus the pKb of the conjugate base has to be equal to 14. So my pKa is then just going to be 14 minus the pKb, and my pKa comes out to be 9.25. All right, so now I think we have everything we need, and we'll finish up the problem on the last slide. All right, so I've collected here all the information that we've determined on the previous slides. I've got my pKa, I've got the concentrations of the conjugate acid and the conjugate base, and so now I just have to plug everything into the Henderson-Hasselbalch equation. So my pH is going to be 9.25 plus the log of the concentration of the base divided by the concentration of the conjugate acid. And when I work out the math, I get a pH of 8.94, which is our final answer.